Good morning, everyone, or good afternoon, depending on where you are. Thanks for joining. We're going to give people about one more minute to jump on the webcast here, and then we'll go ahead and get started. Okay. Again, good morning and welcome. Good afternoon, everyone. Thank you for joining today's QLogic Ethernet with Endless Capabilities webcast. My name is Chris Lorenz. I'm Director of Partner Marketing, and I'm going to be your host for today's call. In just a moment, I'm going to introduce our speakers for today's webcast, but just want to quickly give you a couple housekeeping items. We are actually utilizing a new webcast tool that we're pretty excited about. It's got some nice capabilities, and I want to point out some of those that are available to our audience. There's a number of icons, or what are called widgets, down at the bottom of your screen, and they allow you to, some of them allow you to interact during the course of the webcast. The first one on the far left allows you to see the speaker bio. So even though I'm going to be introducing these two folks here in a minute, you can take a quick sneak preview and kind of see what their role and their background is. You've got the presentation view, so that's the second one. Further over, you've got a Q&A box. So if you have any questions during the webcast, feel free to type them in there. We'll probably address most questions at the end of the webcast, but go ahead and type them in there, and we'll try to get to as many as we can, time allowing. There's also a group chat icon in case you want to share or discuss any of today's topics with the other folks who are also attending. And then the green widget is actually where we have some resources that provide some additional information and content relative to today's webcast, some links to some papers and other collateral that you may enjoy reading at your convenience. And then we've got some social media links here where you can share some of the information about the webcast, some of your thoughts about the webcast, and we encourage you to use those with your own social media accounts. There's also a help button at the very far right if you have any help with any of the technical aspects of the webcast and how to participate. Please let us know. So without further ado, I'm going to introduce our two speakers today. First speaking today, we're going to have Seamus Crehan, who's president and founder of Crehan Research, and Seamus is going to give us some perspective on trends within the Ethernet market, some information that show where is the market going that will help you understand at a high level how to prepare for the changes in the data center around Ethernet. And then we have Tom Spencer, who's going to be joining us, and Tom is Senior Director of Ethernet Product Marketing for QLogic, and Tom is going to cover some of the new announcements, the new technologies and products that we have within our solution and product portfolio that I think you'll be interested in hearing about. So with that, I'm going to turn it over to you, Seamus. Seamus.
Forgive me.
Are you on mute?
Thanks, Chris.
And
hello, everyone. Thank you, Chris. Sorry about that. Hello, everyone. Here I'm going to discuss some trends and delve into some of my research data on the high-speed networking adapter market with, as Chris mentioned, a focus on 25 gigabit Ethernet. Now, before we look forward to 25 gigabit Ethernet, I thought we could first look at what's currently going on. So this next slide here shows high-speed Ethernet adoption, and by high speed, I mean 10 gigabit Ethernet and greater. And up to the end of 2015, that essentially meant 10 gigabit Ethernet and 40 gigabit Ethernet, but by the end of this year, it will mean 10 gigabit Ethernet, 25 gigabit Ethernet, 40 gigabit Ethernet, 50 gigabit Ethernet, and 100 gigabit Ethernet. So lots of exciting new options coming. On the chart, you see that aside from 2013, there's been consistent strong adoption here, and for the latest calendar year, 2015, port shipments surpassed 13 million, which was over 20% annual growth. On the same chart, you can see that 10 gigabit Ethernet accounts for over 90% of high-speed ports, while 40 gigabit Ethernet accounts for under 10%. Now, if we go underneath this a bit further and talk about where these technologies have been adopted so far, we can see that 10 gigabit Ethernet has a fairly broad and diverse adoption. It started with the large hyperscale cloud providers and the Blade server platforms. And of course, since those Blade server platforms have evolved now to be more vertically integrated platforms or hyper-converged, which I think is what the kids are calling them nowadays. Then we also have good 10 gigabit Ethernet adoption on network appliances and in the telco space, plus now on many storage arrays. And finally, there's a rack and tower system in the broad enterprise market. In contrast with this, the vast majority of 40 gigabit Ethernet volume is driven by a small customer concentration, which are a few of the very large hyperscale customers. Now, if we move to the next slide, we show the actual historical data from the prior slide again, but we're also now looking forward to how this is forecasted to play out. So 25 gigabit Ethernet, 50 gigabit Ethernet, and 100 gigabit Ethernet adapters are just starting to come into the market, including QLogic's recently announced FastLink Q45000 series. And I expect these to ramp strongly as early as the second half of 2016. You can also see on this slide that I'm forecasting 25 gigabit Ethernet to ramp stronger than the other two speeds. I think we'll see over 500,000 25 gigabit Ethernet ports this year alone and greater than 10 million ports by 2020, which is approaching about a fifth of the total volume on this chart. From what we can tell, the early 25 gigabit Ethernet volume is probably going to be mostly from the hyperscale cloud segment, but I'm certainly seeing very broad interest from many other segments. And in terms of all the parts of the supply chain here, there seems to be great industry alignment, all the way from the adapters to the switches to the cables, transceivers, test equipment, servers, etc. Additionally, on this chart, you can see that in conjunction with the ramp of these newer speeds, I expect that 40 gigabit Ethernet will plateau and then be surpassed by 25 gigabit Ethernet and later the other speeds due to factors such as more bandwidth per lane and much more effective path to 100 gigabit Ethernet. And also, going back to the prior slide, you might remember the bullet mentioning that most of the current 40 gigabit Ethernet volume is driven by the hyperscale cloud providers. And these customers have shown very strong early interest in soon deploying 25 gigabit Ethernet and 50 gigabit Ethernet. If we take a look at the next slide, you can see a comparison of how long after introduction it took or will take the various high-speed Ethernet technologies to surpass 2 million ports. You can see that I expect 25 gigabit Ethernet to ramp the fastest of all the high-speed Ethernet networking technologies. But you can also see that the forecast models all three newer speeds, namely 25, 50, and 100 gigabit Ethernet, to ramp faster than the prior two speeds, namely 10 gigabit Ethernet and 40 gigabit Ethernet. I'd also like to make a point on the early days of the 10 gigabit Ethernet adoption versus the upcoming adoptions of 25, 50, and 100 gigabit Ethernet. For approximately 5 years after the introduction of 10 gigabit Ethernet adapters, primarily due to memory bandwidth limitations, the mainstream server platforms were still not capable of saturating two 10 gigabit Ethernet ports, which is the most popular server adapter port configuration. Now, the mainstream server platforms are capable of delivering many hundred gigabits of throughput. And then we have solid-state drives becoming more popular, So the network is starting to become the bottleneck. And I know this might sound a bit self-serving since we're doing a webcast for high-speed networking products, but if you think about it, it's no coincidence that companies that are early adopters of higher bandwidth and or it is core to their business have recently turned a microscope on networking. Even though the networking is a much smaller part of their data center spend, it's handicapping the utilization of their server and storage platforms. So I've been talking about the expected faster ramp of 25 gigabit Ethernet. And with this next slide, I list some of the reasons why I have forecasted that faster ramp. First on this slide, and maybe the most important and compelling reason, is that 25 gigabit Ethernet is going to be priced very attractively, and it will offer great value. The accompanying chart on this slide shows that for a small price premium over 10 gigabit Ethernet, you get 2.5 times the bandwidth. And then the chart below that shows how this looks on a dollar per gigabit of bandwidth basis. Here, on this bottom chart, you can see that 25 gigabit Ethernet is expected to offer a significant discount. And by the way, these are expected 2016 prices. So prices this year, and this year in 2016, a 25 gigabit Ethernet connection is expected to be close to half the price of a 10 gigabit Ethernet connection on a dollar per gigabit of bandwidth basis. And for the pricing shown on these charts, it is what the market average per port selling price of the data center switch, or more specifically, the top of rack data center switch, which connects directly to the server, is, plus the per port price of the server adapter. And actually, some of the products coming into the market already are beating this. In the past, I've generally seen the opposite, where the initial prices have tended to be higher than expected. Last thing to remember about these price premiums is that they're initial prices. So the bandwidth discount becomes even greater over the coming years as the price of the newer technology probably falls faster than the older ones. The second reason here is that 25 gigabit Ethernet currently offers the highest bandwidth density. I saw the latest switches are enabling up to 144 25 gigabit Ethernet ports in a 1RU top of rack switch. And related to that, the third reason here is that you're getting the highest bandwidth per lane with 25 gigabit Ethernet. The next reason I listed is that 25 gigabit Ethernet works over existing 10 gigabit Ethernet fiber cabling, so it runs on the same fiber, same number of lanes, and uses the SFP connectors. With the fifth bullet here, I point out that 25 gigabit Ethernet is the best current path to 100 gigabit Ethernet, which is comprised of 4 lanes of 25 gigabit. Now, the end game here is eventually 100 gigabit Ethernet. We probably won't see that deployed much at the server access layer for some time yet, but we will start to see 100 gigabit Ethernet getting deployed further back in the network, namely in the core and aggregation layers. And again, since 100 gigabit Ethernet is 4 lanes of 25, 25 gigabit Ethernet is the most logical and efficient building block here. And the last reason I wanted to mention on this slide is that the immediate interest, which I talked about earlier, we're seeing from some of the largest hyperscale cloud providers should propel strong early volumes, which in turn will benefit in reducing costs even further. With this last slide for me, I wanted to delve a bit deeper into the first point I made on the prior slide, which is how aggressively or attractively 25 gigabit Ethernet is priced. And although there were other benefits listed for 25 gigabit Ethernet, I think price is a real big difference maker here. If we look back at the past decade and a half, the networking demand curve has experienced an amazing positive paradigm shift where we've gone from essentially a gigabyte era to approach a zettabyte era. On the slide here, I've listed some of the factors that have caused that, And I won't go through each of them since we see them listed and mentioned all the time, and rightly so. But, they have profoundly affected our professional and personal lives. Even looking at the first bullet alone, there's been such a dramatic change where combined PC and server shipments were in the few hundred of millions and growing in the single-digit percentages annually. And now, with smartphone, tablets, etc., they're in the billions. And, for someone who's been tracking the data center networking markets for quite some time, what often struck me is that, given the demand curve had shifted so positively to the right, probably exceeding anybody's expectations, why has the upgrade to higher networking speeds been so slow, which is illustrated on this chart here? And I think a big part of that is that the pricing was just too high for volume or mass adoption where there tends to be elasticity. As I showed on the prior slide, it looks like this pricing dynamic would be very different with 25 gigabit Ethernet, hence the faster ramp. Thank you. And now I'm going to turn the call over to Tom Spencer from QLogic.
All right. Thank you, Seamus. Hello, everybody. This is Tom Spencer. I run the marketing group for the Ethernet products at QLogic, formerly from Broadcom. And if we go to the first slide and we look at what happened 2 years ago, so QLogic's been a leader in storage I/O and Ethernet for a number of years. And 2 years ago, the acquisition of the Ethernet products from Broadcom bolstered that position and created a great story for end-to-end solutions. So whether we're talking host side or target side solutions, and whether it's fiber channel or Ethernet technology, QLogic has a complete portfolio now. Let's go ahead and go to the next. So from an Ethernet perspective, we created this segmentation, and I want to explain why we did it this way. Traditional enterprise, everybody knows that there are inflection points right now in the market. Public cloud and hyperscale created this new paradigm in the industry with direct attached storage and different architecture in the data center. And the way I view this is traditional three-tiered structure you found in enterprise infrastructure on the left-hand side, and hyperscale distributed storage on the right-hand side, and then everything in between. And what you find with these different segments, we see that a lot of the characteristics, and I'm speaking from an Ethernet controller perspective, a lot of the characteristics that we find in the enterprise, which is still a big piece of the market today, this would be multiple operating systems. This would be heavy on virtualization, both server virtualization as well as network virtualization, and also running protocol stacks like RDMA, iSCSI, FCOE. Those seem to be moving into the telco, managed service provider, and private cloud markets. There are varying degrees of that statement, but we're seeing that type of activity there and those kind of requirements. And then storage, of course, is its own segment. And if you look at the portfolio that we have, and we'll talk about the capabilities of our products, you'll see that they have a very strong position inside of those vertical markets. In the public cloud, as Seamus was pointing out, this is what is accelerating the 25, 50, 100 gig, and we see a lot of pull-through in the other segments. What I mean by that is the hyperscale infrastructure, they're going to be creating the ability for suppliers to have the kind of volumes that they can now economically sell this technology into the other vertical markets. And so we're going to see 25, 50, 100 take off in these other segments. We already have design wins in all of these segments with 25, 50, and 100 today. Some of those shipping in 2016. I think the public cloud will take off faster, and I think we'll start to see some reasonable volumes in the other segments probably late this year or sometime next year. Go ahead and page down there. So what I want to do, I want to talk about 3 inflection points in the market and how that's affecting Ethernet controller solution again, the endpoints that you find on the compute nodes or in the storage nodes. So the first one we've talked about, Seamus talked about quite a bit. This is the 2550-100, and as he pointed out, go ahead and just build this slide out. 100 gigabit was defined. There was a long debate about whether it was going to be a 4 by 10 or 4 by 25, and the IEEE eventually landed at 4 by 25. Basically, what that created was the opportunity to leverage any single lane application going instead of 10 gig going to 40 gig. With 4 10 gig lanes, you now have 25 gig in a single lane. 250% increase in throughput on any given infrastructure. And so 25, 50, and 100 was born at that time. And you can see there's been a lot of backers on this. We're working with all the ecosystem partners doing interoperability testing for 25, 50, 100. It is very new. We have proof of concepts occurring in the cloud market. We have it in the telco market. We have design wins with all the key OEMs. And page. The second inflection point I want to point out, and I call it software-defined everything. So, it used to be the case where you pick suppliers, whether it's switch suppliers for the networking side or compute suppliers. A lot of manageability and control plane infrastructure was built around the suppliers that were chosen. The change that we're seeing in OpenStack really was one of the first technologies that took a crack at this is let's create an ecosystem where I can plug in what I want to plug in. And in some ways, it commoditizes some of the hardware. It's not quite that simple, but the goal is the same. If I'm going to spend a lot of money on infrastructure, I want to be able to use that infrastructure for different applications, different workloads. I might want to converge my IT department with my data center. So the ability to have an infrastructure that I can set up and tear down and set up and tear down dynamically without a lot of cost is really the goal. So OpenStack created that environment. You have cloud services. If I have a new customer come in, I'm going to be setting up and tearing down services. That's what you see with IaaS and PaaS. Open Compute was and still is an attempt to create standardized hardware. And it's had success in different pockets. There's a lot of success with OCP adapter cards, just the card itself. And we're participating in that space as well. Network function virtualization. This is a kind of doing what OpenStack did to switches. Network function virtualization is doing to appliances that are used in telco infrastructure. So there's a lot of work being done around that space. So really, this isn't just for Ethernet controllers. This is the whole market. Software-defined everything is the goal, and that's where people are trending to. So that's the second inflection point. And if you go to the last one, this one's interesting. So we did some work a couple years ago. We were doing some Hadoop benchmarking to see, what effects we could have. We have some acceleration technology, which we're going to talk about here shortly. And we wanted to study the difference between our 10 gigabit solution with and without acceleration in a Hadoop environment. What we found was there wasn't even much of a difference between 1 gigabit Ethernet and 10 gigabit Ethernet in a Hadoop environment on that particular box we were running. And we found that the bottleneck was in the spinning hard drive. That's where the bottleneck was. Well, now there's this trend going to SSDs. And SSDs are orders of magnitude lower on latency, which has moved the bottleneck back to either the CPU complex or the networking solution. In addition to that, we're seeing higher density storage solutions, whether that's direct attached storage, whether that's a storage appliance, whatever the sheet metal is around the solution, we're seeing higher and higher density. So two things come out of that. We're seeing the need for higher bandwidth on the networking side to get data in and out of these dense boxes. And the other is lower latency on the networking, because now it becomes visible in the overall solution. So now let's look at all the technologies that apply. Go ahead and page down. Let's look at all the technologies that apply to a networking device. So we put this together to illustrate, if you go back 10 years ago, the server virtualization in the upper left-hand corner, a multi-queue solution, that was about as complex as it got for Ethernet. There's been this evolution over the last decade. It really started off more with the storage and low latency, where iSCSI came into the picture. About 5 years ago, FCOE came into the picture. On the low latency side, there's been a battle between RoCE and iWarp. RoCE's been the more predominant technology over the last couple years. Network function virtualization, which has really two predominant use cases. One is multi-tenancy. So in the case of cloud services and you have lots of tenants, it used to be that you could subdivide a network using VLANs, but then you were capped at 4,000 unique IDs or 4,096. With network virtualization or tunneling, they call it, these technologies have a field that allows you to have up to 16 million unique IDs. So it's nearly limitless. And so multi-tenancy is one application and highly virtualized environments is another. So I can have VMs dynamically moving from one compute node to another, whether that's over a geographic area or whether that's in the same rack. And then software-defined everything we talked about is really a whole ecosystem. So if you look at this evolution, there's a lot of technology up there. And then Seamus walked us through the speed evolution. And 2550 is real. It's going to be shipping this year. We already have designs that are shipping this year, and the market's going to move. So where do we come into this picture? The uniqueness of QLogic compared to our two nearest competitors, we have all of those technologies in our architecture, and that is a very unique solution. If I were to map my competition versus me, some of them are better at some pieces of the puzzle and some are better at others. And what we're trying to do is pull that software-defined everything back into the solution so that you're never going to be in a position, if I want low latency and my clients are RoCE-based, we can support that. If I'm running a server that has both RoCE and iWarp clients, I can do that concurrently. I can run iSCSI and FCOE offloads, and I can run NVMe over fabrics. I can run all these technologies concurrently, and there's one other thing that we have that goes over and beyond all the standards. The word we like to use is extensibility. We have the ability through firmware, and this is an architectural difference between us and our competition, to create custom solutions. I'll give you a couple examples. Right now we're working on technology where we can actually do writes and reads directly to NVMe drives without CPU intervention. Very unique. Another technology that we can do MPLS tunneling. Nobody else can do that, and we can implement this on our platform. So the goal that we set out a couple years ago was, let's build a platform that can service all the speeds, that can service all the technologies, and let's have a level of extensibility to allow customization in unique environments. And this is it is a difficult thing to support, but we're doing it. We are number 2 in the 10 gigabit Ethernet market. It's a strong position. We have strong positions at the OEMs. We actually have design wins at all the ODMs for the white box market. So we've quietly snuck our way into this space and put ourselves in the number 2 position. Okay. So most recently, this is our 4th generation technology, the FastLink 45000 series. So this is our entrance into the 2550 100 gigabit space. So we have a family of ASICs, and the first ASIC is now out, and that's being used on these adapter cards. And we wanted to announce the 25 and 100 gigabit Ethernet adapters. And so both of these cards have design wins in multiple places. We will be shipping these cards this year. We announced them at Mobile World Congress on February 22nd, and the products are fully available in this quarter. this will create a whole family of solutions. Now, we're not limited to stand-up adapter cards. We have a whole array of custom OEM mezzanine cards. We have OCP adapter cards that are in the pipeline. So pretty much every form factor that you can think of for an Ethernet controller solution is in our pipeline and is going to be available from QLogic or from our partners. Okay. So looking at the summary, today QLogic is number one on converged network adapters. We're number two overall on 10 gigabit Ethernet. We're a market leader in 25, 50, 100. So from announced products, we're out there in the front. One of our bigger competitors hasn't announced anything yet. They're still working on catching up. The Fastlink 45,000 series. If you think QLogic, the way to differentiate us from everyone else is we have the platform that can support all features, all speeds, and add a layer of extensibility on top of that. That's something unique in the industry. And that's the solution that we're bringing to the market. Okay.
Great. Thank you, Tom, and thank you, Seamus. We have time if any of the audience members have questions for either Seamus or Tom. Tom, we do have one question here that I think is directed at you. This is from Harry, and he asks, could you elaborate on the speed agility of the adapters?
Speed agility, meaning would that be the ability to go from one speed to another on the same adapter
I'm assuming
card?
so. Harry, if we're not interpreting your question correctly, go ahead and add a little bit more detail. We'll try to make sure we get to the answer.
So he can write that, but I think I know where he's going with it. So we have two ASICs that are in this portfolio. One of them can go all the way up to 100. One of them goes all the way up to 50 throughput. Okay, and if you add up any combination of ports, for example, both of those solutions can do a 4 by 10. Both of those solutions can do a 2 by 25. Only one of them can do a 2 by 40, 2 by 50, 1 by 100. The other one is 1 by 40, 1 by 50, and no 100. From a connectivity perspective, 10 gig and 25 gig today share a common cable type. Okay, it's an SFP cage. So in the 10 gig vernacular is SFP plus, and for 25 gig they call it SFP 28. But both of those modules plug into the same cage. So you'll see a lot of, I shouldn't say a lot of, you will probably see products advertised as 10/25, and that actually is great for anybody building new infrastructure because what they can do is they can put a 10 and a 25 gig capable adapter card into their server or storage appliance, and they don't have to upgrade their switch infrastructure until they're ready for it. They can ease into it. Now, not all cables are going to support 25, but some cables will support 25 and 10. So not all 10 support 25, but all 25 support 10, if that makes sense. So those two have a commonality. 40 gig is completely different than all other speeds. It uses a QSFP, different form factor. That's one of the reasons why it didn't scale well. Going from 10 to 40, you had to change your cable plant completely. And then to 100, you had to change it again. 100 uses QSFP 28. Now, there are a couple engagements that we have where customers have decided to use a QSFP 28, that's a 100 gig module, plus a breakout cable. And the breakout cable can fan you out to anything, right? You can go out to 50s or 40s or 10s or 25s. That will not be the most predominant solution, okay? So in your mind, practically speaking, economically speaking, 10 and 25 get coupled, 50 and 100 get coupled today. And then if you take everything I just said and set it to the side for a moment, if you go out and Google RCX, the acronym RCX, you'll find a couple press releases from about a month ago where a couple suppliers got together and came up with a new MSA standard. And think of it as like an SFP cage with 4 quadrants. If you're looking at the front of the cage, each of those quadrants can be a 25 gig lane. So I can do a 1x100, I could do a 2x50, I could do a 4x25, or any combination of that. I don't know how successful that technology will be because it's yet again a whole new cable solution. I think if it's going to be successful anywhere, it's going to be in the hyperscale. We are going to participate in that business. We're going to have adapter card solutions for it. But those, I hope that addresses where the question came from.
Yeah, Harry confirmed that.
You did.
That was, we were addressing it correctly. So yeah.
Yeah. So there are a lot of options, and if you go back to that slide, you don't have to go to the slide, but if you think back to the slide that had all the technologies across the top and all the speeds down the side, you can see from even 5 years ago till now, picking an Ethernet supplier has gotten more complex. We're trying to ease that by having a one-stop shop. So low latency, storage, straight up NIC, tunneling for network virtualization, whatever your solution is, and then having all the speeds.
Right. All right. Thank you for that question, Harry. We actually have several others that we're going to go through here. Chet with Cambridge Computers asks, can you further explain your roadmap for offering MPLS? What software vendors are you working with to enable VNF routers on your cards?
Okay. The MPLS statement is a statement about capability. We're not going to have a standard feature for that, at least not currently today, because that would need a standards body to be involved. We had a couple telcos come to us and ask us. It was interesting because we had one in Europe and we had one in the U.S. ask us the same question within 4 weeks of each other. And our answer was yes. And now, does that mean they're going to go deploy it? I don't know. And, I'll be honest, that's not, we don't just flip a switch and it turns on. There's some work to do. But the capability to do it is there, and it was really a statement about extensibility. So there are no plans as a standard feature unless a standards body gets behind it. But if we have large customers that want to do this, it's something that we can turn on, and we're having that conversation today.
Right. Rick with E+ is asking, or are we aware, do we have any plans for FCOE at 25 gig?
It's TBD. It's TBD because if you look at the market segments that are moving to 25 gig, FCOE today doesn't exist in the cloud. Start with that statement. When I say a hyperscale cloud, right, the big guys, it always comes back to whether or not there's a business case for it. I'm not trying to cop out of the question here. We have it. This solution, these ASICs are shipping, they're going to ship with FCOE and iSCSI. Whether they go on a 25 gig version of it, it's the same drivers, it's the same ASIC. That's really a question. FCOE is strong in blades, and we will continue to support it in blades, and these ASICs are being used in blade platforms. We have programs that are in flight. So the capability's there, and we will be shipping it. On a 25 gig adapter card, we're sitting back for a moment. And really, in order for us to ship it, we can take the card that we just showed you on one of those slides, and it's a regression test. We flip a bit in the card, and the driver already supports it. We already have code. We already have put it on another form factor. It's just a regression test to check the boxes.
Thank you. And Rick had a follow-up question asking if we could recommend any good white papers on 8 gig fiber channel versus 10 gig iSCSI for OLTP response time applications. I don't know if we know any at the top of my head. We can certainly get back to you on that. Yeah,
we'll take that as an action item.
Yeah, we'll follow up on that, and that may even be something Seamus can help with as well. All right, there is a question from Tina at New York Hospital asking, have you tested this with EMC Scale I/O?
Tested what?
The Bastlink 45,000 cards, I assume, is what she's talking about.
That will be another one. Specifically, I don't know.
You can get back to her on that.
We'd have to get back. We'd have to come back to you on that.
We'll take that as an action.
Yeah. I will say this generically, that this solution is touching server OEMs and storage OEMs, and I'll just leave it at that. I don't want to. We're very successful with it, and I'll just leave it at that.
Yeah, I think maybe because I play a role this too is that we're actively testing these cards with multiple ecosystem partners.
That's right.
As they are, most of those take place under NDA until they are officially announced.
That's right.
And as we do go public with any of them, certainly.
That's right.
We can't press announcements and other things. And on a future webcast, I'm sure we'll update on some of the ecosystem partners that have been enabled.
It's a fair statement to say, what we announced are generic channel cards, our stand-up cards that, you can buy, anyone can buy them. Those same solutions in different form factors we have many design wins at multiple OEMs that are in flight, and like Chris said, we can't disclose what those are. But it would be fair to say that we are in that environment.
Keep an eye out for news from QLogic, because I think you'll see some of those announcements here in the coming weeks and months. And we have a question from Tom at Optical Cable. I assume your 25 gig solutions are NRZ based. Please confirm, are you developing any higher speeds with PAM4 encoding?
My understanding, the NRZ versus PAM, the NRZ is the solution that IEEE chose, or I shouldn't say that because 25 gig is not ratified yet. 25 gig is defined in the 2550 gig consortium. IEEE is supposedly going to align with that spec. There may be some tweaks here and there, but my understanding is that's an NRZ solution. PAM4 is being considered for 50 gig serial, which is under investigation right now by technology groups and standards bodies, but it is not a spec. So, and actually that it does, I just said it, but I want to restate it. 25 gigabit Ethernet is supposed to be ratified by the IEEE in July of this year. Okay, and so that's important for anybody who buys enterprise class equipment is going to be hesitant to do so until that becomes a standard. But I believe the industry has converged on the same spec, and that once it's in IEEE, I think people will get comfortable with it.
Another question from Chad at Cambridge, who asked here. Let's see, make sure they got a lot of questions here. Do you plan to support certain storage offloads like erasure codes? All under investigation. So that has come up, and we've had those discussions with the storage suppliers. It's under consideration, and we'll leave it at that. Yeah, and Chet, you asked another question about, which switch partners are we working with the qualifier cards. I'll answer that the same way we kind of answered the question about EMC Scale IO. Anything that's public, right, we can mention those. Yeah, do you do it? Yeah, so we've done public demos or announcements with Arista, Cisco, HP, Dell, Huawei. In all 5 of those cases, we're talking about the Broadcom Tomahawk switch. That's all public information. And we did interoperability with Broadcom early on. Our first public demos were April of last year. Right. We did networking and interop in Las Vegas. We did networking and interop in Japan in June of last year. We did some other industry events. We just did at Mobile World Congress, we took our 100 gig adapter and we did a DPDK demo with 200 gig adapters, so a total of 400 gigabit bidirectional throughput, pushing tremendous bandwidth, and set that up at Mobile World Congress and showed that on an HP platform. That also is public information. Yeah, and Chet, you also asked, will QLogic be releasing 2550 or 100 gig switches? And no, we will not. The switches are not part of that portfolio, so just the cards. No, but the interoperability efforts have been many. Yeah. A question from Brian at SanDirect was, about availability on the 45,000s, and general availability on these cards is targeted for April of this year. We've announced them, and we expect them to be available in the channel in the April timeframe. So your QLogic sales account team will keep you updated on when those are available through distribution purchase. Let's see if I've gotten everybody else's question here. I want to thank all the audience members. This has been a very valuable and interactive Q&A session, so I think that's been hopefully beneficial for everybody in the call. I think that covers pretty much all the questions that are appropriate for the general audience. I do want to point out, just see if there's any other questions that come in here. I'd point out a couple things. First of all, we did have a webcast incentive in place. For the first 25 people that registered and attended today's webcast, you will receive a $25 Amazon gift card. And if you were one of those fortunate people to jump on the opportunity to attend the webcast, you will be contacted via email after the close of the webcast. And also, there will be a survey at the end of the webcast where we really encourage you to share your feedback. We want to make these as valuable as possible for our partners and customers, so please let us know what you thought and what we did well, and if there's anything we can do better moving forward. Let me see if there's any other additional questions. I think that pretty much covers it. So I want to thank our two speakers, Seamus and Tom. But most of all, I want to thank the attendees, the audience members today, for attending, as well as your insightful questions. So thanks, and look forward to seeing you on another future webcast. Bye-bye.